Hello, I wanted to walk through the first wet lab with you just in case there was some uncertainty in the procedure. So at the beginning of every lab, there is a list of materials that you'll need. In every lab, you will also need your safety goggles. So make sure, even if you're just working with water, that you are wearing your safety goggles during the course of the experiment. So this very first lab, we're looking at the metric system, conversions, and how to make measurements, getting used to the equipment that you're going to be using throughout the course of the semester. Okay, so in the metric system, the measurements we're going to make are going to be in milliliters, in centimeters, and so we are going to get used to using that and doing some conversions. While you're using the equipment, it's important to note how precisely you can make those measurements, and it all depends on the number of divisions between the marked measurements. So if you are using a ruler, okay, it has a certain number of divisions between each measurement, and you're going to want to record that for this lab. If you are using a graduated cylinder, again, there's a certain number of divisions. And depending on the number of divisions, that helps us decide how many decimal places we can report our measurement to. So as we're looking at this lab, we also want to keep in mind that there's always errors that occur in the lab, and we're going to look a little bit at what some of those errors could be. Okay, so again, you want to make sure that you're wearing your safety goggles at all points of this lab. So the very first thing that we're going to look at is the safety part of the lab. So I want you to take a picture of the area that you're going to be working and include that paste it into the Excel file that you're going to be turning in. You also want to think about, before we have any issues, how you would deal with certain emergency situations. And so you're write a little bit about what you would do in the case of these emergency situations. Okay. Next, you're going to look at the uncertainty of our measuring tools. So you're looking at the ruler, the graduated cylinder, and also the thermometer. So we have our thermometer, and you're looking at the divisions between the lines. So there is a bulb portion that is below the 0 point of the thermometer, and that is the part that measures the temperature. Okay. And so you're going to record the uncertainties in those measurements. We're also going to be doing mass by difference, and mass by difference, especially when we're dealing with liquids, it is, you can't put a liquid on the balance itself, and so we have to measure a container so that we can subtract the mass of that container off of the measurement. Okay, so we have our scale here. We're going to find the weight of an empty 25 milliliter graduated cylinder. So you want to turn the scale on. If it doesn't read 0 when you first turn it on, tare or 0 is a button that you want to push to make sure that it reads 0 when nothing is on the scale. Okay, then you can put your graduated cylinder on and record the mass of your graduated cylinder. Okay, and if we have a digital item, whatever that last decimal place is, that's where the uncertainty is. Okay, and then we want to fill that graduated cylinder with some water so that we have 5 milliliters of water. And sometimes it's helpful to use an eyedropper, especially when you get close to the measurement so that you don't over pour the liquid into the graduated cylinder. Okay, and then you'll weigh the graduated cylinder again and record the mass so that you can find the mass of just the water in the graduated cylinder. Okay. We're also going to measure the temperature. So we want some ice. I have crushed ice, but if you have ice cubes, that is perfectly fine as well. So we're going to add some water into the ice. Okay. And if your ice is floating, you want to take the temperature up near where the ice cubes are. That will give you the most accurate reading for your ice cubes. And if you have beakers, you're welcome to use beakers in order for your containers. If you don't, disposable plastic cups work really well also. So we're going to put the thermometer in, and we wait until the liquid inside the thermometer quits moving, and then record the temperature to the correct number of decimal points. And again, we want to keep that bulb near the ice cubes in order to get the most accurate temperature. Okay. We're also going to ask you to use a ruler in order to measure, pardon me, the diameter of a penny. So if you find a penny, you want to put your ruler on it. Make sure you're starting at the 0 point of the ruler at the edge of your penny, and accurately record that measurement to the correct number of decimal places. Okay, then you're going to be asked to convert the units, some of the measurements that you made, into new units to make sure that you understand how to do the dimensional analysis. And just so you're aware, at the end of the lab procedure that you've been given, there is a place to collect all your data to make sure that you're not missing any of the measurements that you need. Okay. And then it does ask you to do some conversions. Okay, for section 3, we're going to find the density of water. And the density of water, again, we're going to be using our graduated cylinder and our scale. If it doesn't say 0, you can hit the tare. You're going to start with your empty graduated cylinder and make sure that you measure the mass. Okay. And then we're going to add about 2 milliliters of water, record the mass again so we can find the mass of that 2 milliliters of water. Okay. And you do want to make sure that you're reading the volume as accurately as you can off of that graduated cylinder and recording it in your Excel form or on here, and then transferring it to your Excel form. You're going to use this to make a graph. Okay. Then you're going to add another 2 milliliters of water. Okay. And again, this is where the eyedropper can come in handy. It's not required, but it can be useful to get your 2 milliliters of water, and then weigh the graduated cylinder again and record that mass. So now you should have a total of 4 milliliters of water in your graduated cylinder. You're going to report that for 6, 8, and 10 milliliters. Okay, and then you'll be using that information in the Excel file provided in order to make a graph. And in the procedure, there is information given to you on how to make the graph that you need in order to calculate the density. Okay, so information is given. It shows you some images on how to find different things in Excel. Okay. You're also going to be asked to answer a few questions based on the density that you found from the graph. Okay. And so once you've completed the Excel file, you're going to save it and then upload it into Canvas so that it can be graded. And if at any point you do have questions, please don't be afraid to reach out to me to have those questions answered. Thank you.